या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता.
Sir, I have one doubts. What are the different types of vibrations?
Good question. What are the different types of vibrations? Generally, vibrations are classified into three categories. Natural vibrations. First one, natural vibrations. Forced vibrations. Third one, damped vibrations. What is meant by vibration first? For example, once a particle begins to vibrate, what happens? What actually takes place? Three categories: natural vibrations, forced vibrations, damped vibrations. Let us try to understand what is meant by vibration. Once a body begins to vibrate, what actually happens? Once you strike the table or any bell or any object, we say that it begins to vibrate. The to and fro motion of a particle about the mean position is called vibration. For example, here is the mean position. For example, the particle begins to vibrate or moves up and down. Moves up and down. Sometimes these particles may move to and fro. The to and fro motion of a particle or the motion of a particle about the mean position in upward and downward directions is called a vibration. So generally, sound is produced by a vibrating body. All bodies do not produce sound on their own. Sound is produced by a vibrating body. So basing on this, vibrations can be classified into three categories. What are they? Natural vibrations, forced vibrations, damped vibrations. If a body vibrates with its own natural frequency, it is called a natural vibration. For example, if you strike a bell like this, or suppose you play a flute, or have you ever seen tuning fork? Just you strike the tuning fork with a rubber hammer, it begins to vibrate. Generally, on a tuning fork, it is written that 256 Hz, 512 Hz, like this. That means it is its own natural frequency. Once you strike the tuning fork with a rubber hammer, it begins to vibrate with its own natural frequency. Such a vibration is called natural vibration. Suppose if a body begins to vibrate by the application of applied force, suppose I strike this table like this, the table begins to vibrate. Here the table does not vibrate on its own. Vibrations take place in this table by means of applying force. This force is nothing but applied force. Once the body begins to vibrate, this vibration is called force vibration. The vibration produced in this table as a result of the application of external force. If a body vibrates by means of application of the applied force, it is called force vibration. Whereas the vibration which move with decreasing amplitude, there are some vibrations which go on decreasing with decreasing amplitude. Such vibrations are called damped vibrations. Vibrations of decreasing amplitude are called damped vibrations. Okay.
I have and one doubt. What are the different forms of energy? How does energy transfer take place?
How can I understand the wavelength, amplitude, frequencies and phase?
Good question. Today, she has asked me one doubt. What are the different forms of energy? How does the energy transfer take place? In our day-to-day life, we come across different forms of energy. What are the different forms of energy that we come across in our daily life? heat energy, light energy, sound energy, electrical energy, etc. Generally, we come across light energy and sound energy very often. Sound energy or light energy propagate in the form of waves. Light energy and sound energy propagate in the form of waves. It is something difficult to understand the propagation of a wave in a day-to-day life, but let us make some attempts to understand the different forms of energy which is propagated in a medium. Generally, waves can be classified into two categories: mechanical waves second one is electromagnetic waves. Mechanical waves require material medium for the propagation. Mechanical waves require material medium for the propagation. Material medium in the sense solids, liquids and gases. Solids, liquids and gases are absolutely necessary for the propagation of mechanical waves. Whereas there are some other waves called electromagnetic waves which do not require any medium for the propagation. They don't require any medium for the propagation. They can travel through vacuum also. There are so many scientists who have made several attempts to describe the nature of light. In the sense, Newton's corpuscular theory, Huygens wave theory, Maxwell electromagnetic theory, and there are so many theories which are prevalent to explain the propagation of light. If you have got clear idea about the propagation of energy in any medium, we should have clear-cut understanding about the waves first. The question that she has asked me is, what is a wave and what are the different types of waves? As we have discussed already, light and sound travel in the form of waves. Material medium is required for the propagation of mechanical waves, as we have discussed. Generally, once energy is produced from any object, that energy creates a disturbance in a medium. That disturbance is nothing but a wave. A wave is a disturbance. A wave is a disturbance created in a medium which transports energy without transferring the matter as a whole, without transferring the matter as a whole. This is the way in which you can define a wave. A wave is a disturbance created in a medium which transports energy without transferring the matter as a whole. Suppose I produce a sound by striking the table. It produces sound because vibrations are produced from the table as soon as I strike the table. The sound produced from this source moves in the form of a waves. That means this sound creates a disturbance in the medium, thereby it travels from the source to the human ears. But the sound itself does not move from here to there. What actually moves from here to there is energy only. What actually moves from here to there is energy only. So a wave is a disturbance created in a medium which transfers energy without transferring the matter as a whole. Means matter itself does not move from one point to another point. Only energy transport takes place. Suppose once you strike a bell, the bell begins to vibrate. The vibrations produce sound in the air. That means, in other words, it creates a disturbance in the medium. Thereby, it moves from one point to another point. The disturbance travels in the form of waves. I will tell you what are the different types of waves in the. He asked me is what is wavelength, amplitude, frequency, and phase. We have already discussed that energy transfer takes place in the form of waves. I already told you that a wave is a disturbance which is created in a medium which transports energy from one point to another point without transferring the matter as a whole. So let us discuss the terminology connecting with the propagation of waves. First one is wavelength. Wavelength. Just before you understand the term connecting with wavelength, mechanical waves I told you. Mechanical waves are of two types. What are the different types of mechanical waves we discussed? Longitudinal waves. Longitudinal waves. Second one is transverse waves. Longitudinal waves, transverse waves. Suppose here is the position of the sound box or any bell. If you happen to ring this bell, it begins to vibrate. The vibrations are produced in the medium from one point to another point in the form of a disturbance like this. You know that the wave is nothing but a disturbance. This disturbance transports energy. Transports energy. Here, there are some points where the particles come close to each other. Some points are there, particles move away from each other. There are some points where the particles come close to each other. The points where these particles come close to each other are called compressions. What are these points called? Compressions. Here these points are called rarefactions. What are these points called? Rarefactions. These compressions and rarefactions take place in different equal intervals of length. Here, when we observe here, these two are two compressions. Two compressions which are nothing but the compressions which come one after the other. In other words, consecutive compressions. Here the distance between two consecutive compressions are rarefactions. Is here wavelength. In other words, these are the points where the particles have come close to each other. Here are the points where the particles move away from each other. The distance between two successive compressions, two successive rarefactions is called wavelength. This is the letter called lambda, which is used to denote wavelength. What is the letter used to denote wavelength? Lambda. Lambda. So therefore, this type of waves are called longitudinal waves. So let us try to understand what is meant by longitudinal wave. If the direction of the propagation of the wave is parallel to the direction of the propagation of the sound, it is called a longitudinal wave. For example, wave is moved in this direction. Particles also vibrate to and fro in this direction. Therefore, this wave is called a longitudinal wave. The particles of the wave vibrate parallel to the direction of the propagation of the wave. It is called longitudinal wave. There are some cases where the wave is like this. Here, particles vibrate perpendicular to the direction of the propagation of the wave. So this is the direction along the wave transverse, but particles vibrate perpendicular to the direction of the propagation of the wave. There are some points where the particles undergo maximum displacement. Here are the particles which undergo minimum displacement. The particles which undergo maximum displacement are called crests. The particles which undergo minimum displacement are called troughs. The distance between two successive crests or troughs is also called wavelength. What is this called? Wavelength. Here, these are the 2 points which are said to be in phase. These are the 2 points which are said to be in phase. Similarly, these are the 2 points which are said to be in phase. Therefore, wavelength is nothing but the distance between 2 points which are in phase. Which are in phase.